Hello students, I am Ashish Chore, Assistant Professor in Computer Science and Engineering Department in SIRT Bhopal, and we cover today both multiplication algorithm. In today's topic we cover introduction of both multiplication algorithm, prerequisites to solve the questions, and flowchart of the both multiplication algorithms, and the description and some key points and example. So let's start. In the introductory part, the Booth algorithm is the multiplication algorithm that allow us to multiply the two signed binary integers in 2's complement respectively. It is also used to speed up the performance of the multiplication process. It is very efficient. The algorithm was invented by Andrew Donald Booth in 1950 London. Some prerequisites to solve the questions: decimal to binary conversions, sign magnitude representations, and micro operations. And these all things we already covered. So let's see the flowchart of both multiplication algorithm. In the step first, multiplicand in BR and multiplier in QR. BR and QR both are registers. AC is initialized by 0, Qn plus 1 is initialized by 0, SC is initialized by n. After that, we check the value of Qn and Qn plus 1. There is a total 4 possible combinations, that is 1 0, 0 1, 0 0 and 1 1. If in case of 1 0, we perform the operation AC plus BR bar plus 1, and if we got 0 1, then we add the BR value in the AC, and after that, if in all 4 cases including 0 0 and 1 1, we perform the arithmetic shift right operation on AC and QR, and SC is decremented by 1. After that, we check the value of SC. If SC is equal to 0, then end the process and our answer is in AC and QR. If SC is not equal to 0, then the process is further continue and we check the value of Qn and Qn plus 1 till SC is going to 0. Okay. In the next step, there is a flowchart descriptions. In the first step, multiplicand in BR and multiplier in QR, I already told you BR and QR both are the registers. Okay. In the next step, AC initialized by 0 and Qn plus 1 is also initialized by 0. SC is a sequence counter that represents the total bits set to n, which is equal to the number of bits in the multiplier. After that, we encounter the 2 bits of the multiplier as Qn and Qn plus 1, where Qn represents the last bit of QR and Qn plus 1 represents the incremented bit of Qn by 1. There are 4 possible outcomes of Qn and Qn plus 1, that is 1 0 0 1 0 0 and 1 1. Suppose 2 bits of the multiplier is equal to 1 0. It means that we have to subtract BR bar plus 1 is equal to minus BR, or it is the 2's complement of BR. The multiplier from the partial product in the accumulator AC, and then perform the arithmetic shift operation, arithmetic shift right, including Qn plus 1. If the 2 of the multiplier equal to 0 1, it means we need to perform the addition of the multiplicand to the partial product in accumulator AC and then perform the arithmetic shift operation including Qn plus 1. If the 2 of the multiplier equal to 0 0 and 1 1, then directly perform the arithmetic shift operation including qn plus 1. The arithmetic shift operation is used in both algorithms to shift AC and QR bits to the right by 1 and remains the sign bit in AC unchanged. This is the very important point. And with every shift operation, decrement the value of SC, and the SC sequence counter is continuously decremented till the computational loop is repeated equal to the number of bits. If the value of sequence counter is not equal to 0, then again check the value of 2 bits of the multiplier as qn and qn plus 1, else the value of SC is equal to 0 means end the algorithm, and we got the answer in AC and QR. Okay. Now there is some key points. This is very important points. In both algorithm, always take sign bit in BR and QR. Initially, number of zeros in AC should be equal to the total digits in multiplicand, that is BR. Okay. Next point, SC represents the number of multiplier bits QR, and it is a sequence counter that is continuously decremented till equal to the number of bits n or reach to 0. Number 4, discard the overflow or extra bit while adding or subtracting the BR to AC. Number 5, the arithmetic shift operation is used in both algorithms to shift AC and QR bits to the right by 1 bit, and the sign bit, leftmost bit of AC, remains unchanged. Okay, these are the basic points or very important points of Booth multiplication algorithm. Now let's take an example. Solve the question by Booth algorithm. There is an example of 15 into 13. Here we have two numbers 15 and 13. First of all, we need to convert 15 and 13 into binary numbers, like 15 equal to 1111 and 13 is 1101. But according to the first key point in Booth multiplication algorithm, always take a sign bit in BR and QR. So now set 15 equal to 0 1 1 1 1 as multiplicand in BR, and 13 equal to 0 1 1 0 1 as a multiplier in QR by sign magnitude representation. According to the flowchart algorithm, initial value of AC equal to 0, but the question is how many zeros, and the answer by second key point. Initially, number of zeros in AC should be equal to total digits in multiplicand BR. So here multiplicand BR have a total 5 bits, means in that case initial value of AC is 5 times 0, that is 0 0 0 0 0. Now according to the flowchart algorithm, initial value of qn plus 1 is set to 0, and the sequence counter represent the number of bits n, and have here we have 5 bits, so set the SC equal to 5. Now as well as we also require the value of BR bar plus 1, that is minus BR, for subtract operation. So BR bar plus 1 equal to 1 0 0 0 1. Now we have all the value to solve the questions. What values? We have the value of BR, QR, BR ka bar plus 1, AC, QN plus 1, and sequence counter. We have all the values. So just start to solve the questions. Now in the first step, just arrange the values AC, QR, Qn plus 1, SC and operation format. Initial value of AC is 0, 0, 0, 0, 0. QR value is 0, 1, 1, 0, 1. Qn plus 1 is initial value is 0. SC is 5. Now check the value of QR and Qn plus 1. ठीक है. There is a last bit of QR is Qnth bit. So check the value of Qn plus Qn plus 1. I just dark or bold this bits. There is 1 and 0. So in case of 1, 0, we perform the operation, subtract operation. So add the value of BR ka bar plus 1 in AC. That is 1, 0, 0, 0, 1. After adding, we got the same value 1, 0, 0, 0, 1, and remaining all the value are same. Now shift the value by performing arithmetic shift right operation and decrement the value of SC by 1. So SC value is 4 and decrement the and shift the value of AC and QR. After shifting, the value is 1, 0, 1, 1, 0, 1 and 1, 1, 1, 1. Okay. Now again check the value of SC. If SC is 0, then algorithm is end, but here we have a SC value is 4. So again check the value, and that time we got the value of Qn and Qn plus 1 is 0, 1. That means we add the value of BR in AC. Okay, now the value of BR is 0, 1, 1, 1, 1. This value going to add in AC. After adding, we got the value 1, 1, 1, 0, 0. In that case, we have an overflow condition or overflow bit that is discarded. Okay, this is I also cover in the my key points. So just remember this thing. Okay, now next step, shift the arithmetic shift, perform the arithmetic shift right operation and decrement the value of SC. So SC value is 3, and after shifting in right side, the value are 0, 1, 1, 0, 1, 1, 1, 1, 0, 0, 0, 0. Okay, now if the value is not going to 0 in SC, so again check the value of Qn and Qn plus 1. In that time we also got the value of Qn and Qn plus 1 is 1, 0. So subtraction operation is performed here. So add the value of BR bar plus 1 in AC. After adding, we got some values. Just check it here. And after that, we also perform the arithmetic shift right operation and decrement the value of SC. After decrement the value, we have SC value is 2 and Q. Again check the value of Qn and Qn plus 1, that is 1, 1. So no addition or subtraction operation is performed here. Direct just perform the arithmetic shift right operation and decrement the value of SC. Okay. After decrementing the value of SC value is 1, and after shifting the value is 1, 0, 1, 1, 0, 0, 1, 0, 1, 1, 1. Okay, now again check the value of SC. So there is 1. So in Booth multiplication algorithm, there is a 0, 1. We got 0, 1 So again we perform the addition operation and add the value of BR in AC. So after adding we got the value 01100 and QR value is 00110 and SC is 1. Now perform the operation arithmetic shift right and SC is decremented by 1. So after shifting the arithmetic shift right operation, we have a value 01100 and the SC value is going to 0. Now check the value of SC. There is a value of SC is 0. That means the algorithm is going to end. Okay, and our answer is stored in the AC and QR. So stop the algorithm. Okay, now check the answer. The numerical example of Booth multiplication is 15 into 13, that is equal to 195, and the binary representation of binary 195 is 0011000011, that is equal to our binary number stored in AC and QR. So the answer is correct. Okay guys, so this is the method that we use in Booth multiplication algorithm. In Booth multiplication algorithm, just remember the all key points. That is very important for you. Okay, thank you everyone